So what I'm going to do is just walk through a bunch of examples and convert to scientific notation. Let's take the case where we have 820,000. Step 1 is to do the caret thing. So starting on the left, our first non-zero digit is 8. We'll put a caret to the right of the 8. Our next move is to count. We started with the decimal at the end. We're going to end up with the decimal where the caret is. So we're going to have to move 1, 2, 3, 4, 5 places. That means our power will have the magnitude 5. But we don't know about the sign, so let me just make that the absolute value of our power. To decide what sign we're going to have, ask, are we going left or right? Well, we're going left, so it's going to be a positive power. So what are we going to do with this? Well, the caret tells us where to put our decimal. We just take the non-zero digits and we write them with the decimal point, 8.2. It's going to be times 10 to some power. In counting how many spaces we moved the decimal, we got the power, the magnitude, the absolute value of the power, as 5. And because we moved left, it's going to be positive. So written in scientific notation, 820,000 is going to be 8.2 times 10 to the 5th power. Let's look at a fraction. And we'll make it a negative number on top of it. Take negative point. 1, 2, 3, 4. 4 zeros, a 7, and a 2. And oftentimes you'll find people in labs talk about 4 zeros, 7. Because they get tired of saying times 10 to the negative 4. Happens more often talking about purity with 9s. Our first move is to place a caret. So we start on the left, and we move to the right looking for a non-zero digit. The winner is 12. Not 12, 7. We put the caret between the 7 and the 2. That's where our decimal point is going to end up. Our second move is to count to find out the magnitude of the power. And that decimal is going to move 1, 2, 3, 4, 5 places again. Answer 5. And the third thing we have to do is decide whether it's positive or negative. So, let me move this up. If we move to the left, we'll have a positive sign on our exponent. If we move to the right, we'll have a negative sign. This is going to move to the right, so we will have a negative exponent. What we'll do then is we'll take the non-zero digits, so we have 7.2, and we'll multiply that by 10 to the negative 5 power. Then we're going to look back and check whether we actually have finished the problem. And the answer is no, we haven't, because I haven't brought down yet this negative sign. The whole thing was negative, so there needs to be a negative out front. A different type of negative And this negative tells us we're left of 0 on the number line, and this negative tells us we're basically dealing with a fraction less than 1. Okay. Let's undo scientific notation. And to undo it, we're going to reverse the process. So the instructions you will get, typically, are to write in standard notation. And we'll just reverse the recipe, pretty much. Let's take the numbers that we did work with, or at least one of the numbers we worked with already. 8.2 times 10 to the 5th. Well, step 3 was to decide whether we had a positive or a negative exponent. Going backwards, we'll say, starting with step 3, so I'll just write 3, 2, 1. What do we have? We have a positive exponent, so that means it was moved left before. So to undo, we're going to move right. Well, the second thing we had to do was find out how much we moved it. And the answer is 5 places, because that is the magnitude of our power. And then, of course, where does the decimal start? Well, that one doesn't play as big a role. It was simply the caret thing between the 8 and the 2. It's already there for us as a decimal. So what we'll do is we'll take 8.2 and simply move 5 places to the right. 1, 2, 3, 4, 5. Our decimal now resides at the end of our number, and every one of these holes gets a 0 in it. Our number was 820,000, and you have the option of putting in the comma or leaving a space, depending on what textbook you're working with. Let's take a number with a negative power. Different color pen. Suppose we have negative 6.1 times 10 to the negative 4th. So it's similar to the last one that we did. Well, we are going to start out with a negative sign somewhere or other. And I have a negative power, so I know I'm going to have a string of zeros in front of the number. The negative power was acquired by moving the decimal to the right, so we'll undo by moving left. So I need to leave some room on the left. And how much? Well, step 2 was how many places? We're looking at 4 places. So write down the 6.1 and go 1, 2, 3, 4 places left. There's our new home for our decimal point. Fill in the holes with zeros. In standard form, this is negative 0.00061. Oftentimes that is written 0.00061. Either one is correct. So what we want to do is not just spend our time moving back and forth between forms. That's where you start and you practice, but there's a reason for using scientific notation. It makes calculations easier.